Hey guys, this is Ms. Brenda. We're looking today at lesson 5.3, finding unknown measures in similar figures. Write down the vocabulary term, indirect measurement. The definition of indirect measurement is using similar figures to find a missing measurement that is difficult to measure directly. So think about trying to find the distance from the Earth to the Sun. That's not something you can go out and just measure directly. So we would have to use another method. Okay, so let's look at example 1. The two triangles are similar. And they have to tell us that. If we don't know that the triangles are similar, we can't use this method. Find the value of x. Okay, so take a minute, pause the video. Make sure you've drawn those triangles on your paper and labeled their side. So we're going to start by writing a proportion, setting up two equal fractions that we can see in this, based on this picture. If I start with this side right here, 6 meters, I know that it corresponds with that side of the other triangle, 9 meters. Since I started with a smaller triangle on the top of that ratio, I need to put the smaller triangle on the top of the other ratio. So look now this side, which is 8 meters, and that corresponds with this side, which is x. Now it's just solving a proportion. And you guys are really good at this. We can find cross products. When we do this cross product, we get 6 times x. I like my variable on the left side, so I'll put it over here. The other cross product is 8 times 9, which equals 72. And since I know that 6x equals 72, I put an equal sign there because we know that cross products of a proportion are equal. Now it's some algebra. We need to solve for x. We'll divide both sides by 6, which means that x is equal to 12. Looking at the picture, I can see that x is 12, and they were measuring everything in meters, so that must mean x is 12 meters. Okay, let's take a look at number 2. Number 2 says the two quadrilaterals, and the quad means 4, so these are just 4-sided figures, are similar. The ratio of their perimeters is 12 to 5. Find x. Okay, well, we know that the ratio of their perimeters is equal to the ratio of two corresponding sides. So we'll start by writing the first ratio in our proportion will be the ratio of their perimeters, 12 to 5. Since they have the larger one on top, that must mean that I need the larger quadrilateral's corresponding side on top. So I'll put 15 on top of the other ratio, and then x on the bottom. So we have the larger side, the larger numbers on the top, the smaller numbers on the bottom. Okay, now we're just going to do cross products property. 12 times x is 12x. 15 times 5 is 75. And I know that cross products of a proportion are equal. So now it just becomes a little bit of algebra. We need to divide each side by 12. Which makes those cancel out. And x equals, get a calculator out here and help us do this, 75 divided by 12 So 6.25. If you look at the picture, we can see that we were measuring in inches, so it must be 6.25 inches. Next, we'll look at example 3. You can go ahead and sketch that palm tree and the person. You might just want to use a little stick figure. Make sure you have the triangles, the right angles, and the sides. H, feet, 15 feet, 6 feet, and 3 feet. All right, so question 3. Assume, whoops, here we go. Assume the triangles are similar. We can assume that because the triangle is formed by the palm tree and its shadow, and the man and his shadow. And their shadows are both cast by the same sun, so they're going to be similar triangles. Triangles are similar. Find the height of the palm tree. Okay, so let's set up a proportion. For the first ratio, I'm going to use the palm tree. So I'll put the height of the palm tree, which is h, on the top, and the shadow on the bottom, 15. And that's going to be equal to the ratio formed by the man and his shadow. So his height is 6 feet, and his shadow is 3 feet. So I'm going to double check my proportion. The ones on the left, h and 15, come from the palm tree. The ones on the right, 6 and 3, come from the man. The ones on the top, h and 6, are both the height of the palm tree and the man. And the ones on the bottom, 15 and 3, are their shadows. So I know I've got that set up correctly. The next thing I want to do is find the cross product. So the first cross product, h times 3, that's 3h. The next cross product is 6 times 15, which is 90. And I know that those are equal. So now we need to solve for h, which means I need to isolate h and need to divide itself. So I'll divide both sides by 3. And that cancel out. And that leaves me with h on the left side, and 90 divided by 3 is 30. So let's look at the picture. They were measuring everything in feet. The height of the palm tree says h feet. So that means that the palm tree is 30 feet tall. And let's see if that's reasonable. That makes sense? Well, yeah, the man's shadow is half of his height. So if the palm tree is 30 feet tall, half of 30 would be 15. This is a very reasonable answer. Okay, so let's look at the summary of this lesson. Since we know that corresponding side lengths are proportional, we can use proportion to find the missing measurement just by solving our proportion. I hope you've enjoyed this lesson. And don't forget that you can try some of the odd problems from the textbook and check your answers in the back of the book so that you know if you're ready for your classwork. And I will see you in class.